tree was struck by lightning, and this is the reason you don't go under a tree in a thunderstorm. You would say, well, yeah, doesn't the lightning go through the tree and I'm okay? No, the lightning goes through the tree and boils the sap in the tree, and there's a steam explosion. And notice the shrapnel around here. This would not have been a good trail to be on when that lightning struck that tree. Okay? So occasionally I get out of my demo lab and go out and do stupid things. My wife calls my vacation acts of incredible stupidity. Okay? And so in 1990 I decided I was going to go climb Mount Whitney, which is the highest point in the lower 48 states. Okay? Now that means, of course, that we should have a Surgeon General's warning on it, okay, that like cigarettes, it's hazardous to your health. And in fact, it turned out that it was, okay? When I arrived in 1990, they were taking bodies off the summit of this mountain. 3 people had died there, and they died in this summit hut. This hut was built 70 years ago using the rock at the top of the mountain, and they put a corrugated steel roof on it. It was put there 70 years ago, maybe probably 100 years ago now, essentially as a shelter for climbers, so that if they got caught in a storm, they had a place to go to get out of the storm. The problem, of course, was it made you think you were okay on the summit of the mountain. Lightning struck the metal roof, passed through the roof, went into the place, and of course struck the people in the building and killed them. Okay, so obviously I got up there on a nice day, no thunder, no lightning, I could take pictures, everything was cool, all right, which is kind of dull and boring. So I figured I had to go back and see if we could tempt fate again. So in 2003, I went back, and lo and behold, another annoyingly clear day, and I didn't die, okay? But I took another picture. And in this picture, it looks the same except for 2 significant changes. Number one, the Park Service's lawyers said, you've got to lock that house up so nobody's even tempted to go in there in a storm. So they bolted up the windows, you can't get in. Number two, they said, you know that guy Franklin 300 years ago? Like, that probably wasn't a bad idea. Let's put these spikes on the roof. This was Franklin's idea, and of course he suggested this in colonial Philadelphia. In colonial Philadelphia, they were building lots of churches. They had tall steeples, and they were made of wood. And when lightning struck the tall steeple, the church caught fire, burned to the ground, and all the folks who went to the church were pretty sad that they lost their church. So what exactly happens here? Well, Franklin said, well, you know, what we got to do is give this lightning a path to the planet Earth that takes it outside of the building. So he put these big heavy wires in that would let the electricity go along a path that wasn't at risk from sparks. And so they did this with the building at the top of Mount Whitney. You might suspect that the Chrysler Building in New York has got a really fat hunk of copper running all the way down to the ground so that it's not as exciting a place to be when lightning strikes, because it sure strikes there. And so we would like to take a look at how that works. And so we've got our own little house. It's got a chimney. It's got a lightning rod, okay? And the lightning rod follows a strap-down gear, and this connection goes through my wire to the electrical ground, okay? Everything's just peachy. We need lightning. I just so happen to have lightning, okay? So this is a Tesla coil. It does a reasonable imitation of lightning. Oh. Oh, okay, right. Cool. All right. So with the lightning rod, of course, nothing should happen. This should cause terrible outcome. It doesn't. Pretty boring. Okay, what's this guy doing? Well, the problem, of course, is we need to have something that has a bad outcome when a spark hits. So we need to somehow change the character of this house. This house is sweet baby. What's it do here? This is bang sight that you use for those carbide cannons. We're going to take a little bit of this stuff. Carbide cannons are those things that they use at half, you know, when people score touchdowns. Calcium carbide, when mixed with water, creates acetylene gas. Acetylene gas, there are many gases that burn, but most of them require you to know chemistry. You've got to mix them right. I'm a physicist, I can't do that. Acetylene almost doesn't care. Any mixture of acetylene and air is pretty close to explosive. Okay? Just what we need. So, when we dump this in water, it produces acetylene gas. So we've got our house here. I have a cord I can pull that's going to drop the calcium carbide into the water. Put our house together, we seal it up nice and tight. We now have a house that will tell us if the lightning gets in, right? If we get a spark in there, who knows what's going to happen? But it may be a hint that we put this big hunk of plexiglass. Because this hunk of plexiglass ensures that at least half the people in the front row will survive. So, put the lightning rod on here. Now, if you listen closely up front, you can hear when this drops in the water, it fizzes as it makes this gas. We're going to close that. Make sure the house is all tight. Drop this in. Get up here, you loser. Okay, here we go. Ta-da, the lightning rod works. Thank you very much. We have to show that it makes a difference, don't we? What if we didn't have the lightning rod?